Hello, everyone. This is Adam Pintar with the Statistics Division of ASQ. I would like to welcome you and thank you for joining us. Our speaker today is Dr. Kim Hochman with DuPont Electronics and Communications. Kim received her PhD in statistics from Virginia Tech, and her primary area of statistical expertise is experiment design. Kim was with the DuPont Applied Statistics Group for 26 years. She joined the Electronics Group in 2015. She's a certified project management professional. She leads large growth projects pre and through commercialization and is passionate about enabling data-driven decisions. So I think we can all agree that data-driven decisions are very important. She's a member of ASA, ASQ, and PMI. She is a past chair of the ASQ Chemical and Process Industries Division, and she was on the ASQ Board of Directors from 2010 to 2012. The title of her webinar today is Statisticians as Innovation Leaders. All phones and microphones other than the presenters have been muted. So if you have questions or comments during the webinar, please use the questions interface in the GoToWebinar control panel. Kim will address questions during breaks in the presentation. At this time, I'm going to hand things over to you, Kim, and thank you again for presenting with us.
Thank you, Adam. Can everybody hear okay? Adam, I guess you're the only one that can answer me. So I'm assuming everybody can. And,
well, you can type a yes or no in the questions box. Anybody that can't, you could type a no in the questions box.
Great, great. So as Adam said, this is the talk that I'll be presenting today. I would like to give Willis Jensen equal recognition here. We put this paper together for quality engineering last year. So he is my co-author on this. We presented this at the Fall Technical Conference last year. And so this is a representation of this topic. I'll be going through just a couple charts to give you some context of where I work, look at innovation process in general, then get into statisticians and statistics and their roles in innovation, some examples, and wrap up with some skills statisticians may need. And as Adam said, I will be happy to entertain questions as we go, as I see them here. But I may not look every single chart, so I'll take some time breaks to look for questions. So DuPont is in the middle of, if you're familiar with the news, you might not be as interested as I would be, of course, is in the middle of a merger with Dow Corporation, and after that we'll be splitting into three companies, and these are the three companies listed here, yet to be named, but one will be in the agriculture area, one will be in material science, and one will be specialty products. At the merge, which is pending right now, should happen next quarter, we're going to be organized into these three divisions. And the thing I wanted to point out is that innovation is critical for all three of these divisions to be successful. So we see in their top document, pipeline and robust pipeline, and that means lots of new products coming through toward commercialization for agriculture. We see low-cost integration and innovation huge for the material science company. And in specialty products, it's pretty much by definition, being specialty products, that world-class innovation is going to be critical. And that's where I reside. I am in the specialty products group. The businesses shown here are protection solutions, nutrition and health, industrial biosciences, and the biggest one here is electronics and communications. And that's where I reside, and that's what we're merging. In this division, the only thing coming from Dow would be electronic materials business. So we are in the middle of a merge, but most of what I'll be speaking about today, the innovation processes and such, come from the legacy DuPont and were used across all three, or all of our entire corporation in some form or another, and is still in use. So again, just to highlight the importance of innovation, in AGCO, we're talking about robust innovation pipeline. In Material Co. or company, we talk about value-added innovation, and I'll be talking about value proposition this morning or this afternoon. And in Specialty Co., this is the core strength, product innovation and application development. So in these market segments and in these product lines that we're organizing together into Specialty Products Corporation, they have relatively short life cycles and need improvement continually. So product innovation is critical to us. So with that, I'm going to jump right into what does this innovation process look like, and what role and why do I think statisticians are cut out to being leaders in this space. Well, innovation, we need a definition, so we picked one from the paper from Jensen and colleagues in 2012, as innovation is the process of translating an idea or invention into a good or service that creates value for which customers will pay. So this is really the intersection between marketing excellence and technical excellence. Where they come together is what we call the innovation space. And that's where there's opportunity and capability together. And so that's what we're talking about, and the process resides. So you need technical and marketing competencies to be successful in innovation. The pivotal piece of this process, and it is more early in the process, I'd say, but the pivotal mark of a innovation process is what we call the value proposition. And this is the promise that we're making to customers in our target markets that we intend to deliver on, and that will enable us to capture value. They will capture value, and we will therefore be paid. So what is a value proposition? What goes into the promise? Well, it's got to be something that is relevant, differentiable, and credible. And by that, we mean it meets the customer needs. So whatever we're promising meets an important customer need, should be in the top 3 customer needs. That makes it relevant. It's differentiable, which means the competition can't do it. So it's value that we add relative to the competition, or what we call the next best alternative. That makes it differentiable. And why should the customer even believe our promise? Well, because it's in the area of our strength. So we've got something to bring to the table to convince the customers that, yep, we're capable of doing this, and therefore this is a credible promise. So those 3 things come together to create what we call a value proposition, and then that's what our process, our innovation process, delivers, is this value. This is a more complicated picture, but it's got lots of pictures on it. This shows how DuPont pulls this together, and in the upper left you see our marketing, some of our marketing work, the customer-focused strategic marketing process that could define what the need is, what we should be working on. And in the bottom left, we have DuPont competencies. Now, of course, this is changing right now, and it's going to be divided into 3, and things will be added from Dow and all that. So don't get too interested in what the little honeycomb sections say, but these are our core competencies that we bring to the table, or our leverageable technologies. So we put these things together, and when a marketing need and a competency come together, we will start what's called an innovation process. We call this our product commercialization framework. This series of triangles in the middle here, that's how we execute our innovation process, taking the idea through to a launched product that brings value or creates value for the customer. So that's the process that I'm talking about, statisticians being good at leading and statistics having a relevant role to play. Keep in mind that I'm not talking about innovation in statistics, but statistics in innovation. Both are important. Papers have been published in both areas. For innovation in statistics, we're talking about what new statistical tools need to be developed to solve different kinds of problems. So these might be things that researchers in statistics would come up with to enable us to do new things in statistics. So some of the areas listed in the green box are just some ideas on where some creativity might be beneficial, might be useful, some data efficient methods, small sample, an example of that might be a small sample market research method, business to business conjoint studies. Most of the literature I've seen has been business to consumer, so business to business conjoint. How do you manage some of the nuances of that? Software integration of pricing models. So whenever you're doing innovation, you're dealing with finances, and some of the statistical software is void of that. So somehow integrating popular financial and pricing models that are out in the industry would be helpful, because it'd be really nice to be able to do some statistical analysis on what are the variations of the inputs in this model, how will that impact the outputs, and so forth. So some good research in that area. Creativity training for statisticians. So some statistics students can come out and be very good at number crunching, but they don't think creatively necessarily. They think very, very linearly. So that's something that some training would be helpful. Giving them practice in innovation, learning the language of marketing, be very helpful, along with the pricing models. That kind of goes in the same bucket there. And now new, maybe not so new, but getting increased attention and maybe being the buzzword of late is predictive analytics and big data. Not necessarily being the same thing, so there's a comma between those things, but big data and predictive analytics is having a lot of impact on new product innovations as we try to move toward Internet of Things and Internet of People and things like that. So while that's all I'm really going to say about innovation in statistics that might be useful, where I'm going to focus is statistics in innovation. And that's not creating any new statistics, but it's applying them in creative ways to solve innovation challenges. So this is a list, and you'll see this again later, of just the ones that I could think of off the top of my head. I mean, the most commonly used, I think, statistical methods that we use across the innovation process. Somewhat ordered from beginning to end, but not necessarily. So, and some of these are more technical than others, but I'd say they're all in the quantitative statistical thinking or statistical analysis ballpark. And you'll see these again. So this is the process then. It is a process. It's not a sudden idea that we have. We say, I had an idea, therefore I'm innovative. No, it's how do we take that idea and then take it through to a launched product. It is a long sequence of innovation and experimentation and discovery. So while there's a movement from left to right, there are cycles within each one of these triangles of experimentation, ideas, hypotheses, experimentation, discovery, new hypotheses, and so forth. As we move from the left to the right, some of the first things we have to ask are, who is this for, or who is the customer? Who defines what success looks like? What problem are we trying to solve? Why do we want to serve that customer? I mean, customers choose us, but we can choose customers as well, and indeed we do choose customers by the products that we introduce. And what unmet needs do the customers have? If you have an idea and it doesn't address one of the top few needs that a customer has, in many cases that should be a red flag that it's not likely to be successful. Now on this chart there's also this light bulb in kind of a strange place. Used to be we would start out saying, I have an idea, let's do it. And now we're saying, no, not really. Where we really want the ideation is after we've talked to the market, we've asked a lot of questions about what their objectives are, what their problems are, what would they be happy to see, what are their pains, their gains, all that kind of stuff. We do some market assessment, identify market needs, and then we try to look at what kind of concepts might satisfy those needs. So we haven't really done any technical work. We're just saying, okay, if we had such and such, it would satisfy that need. So can we do that? Let's try. And then we start brainstorming on how might we do that. So should we do it is the first question, and then how might we do it? We need a lot of creativity there. So we're kind of flip-flopping the market research with the idea generation because we want to do idea generation more specific to a market need. If that makes sense. In this chart, we have product development across one axis and customer development on the vertical axis. And this is mentioning that we really need to balance the internal development and knowledge and understanding with external input to this. So product development, I think everybody would agree, if we just did product development without connecting with the customer until the very end, we're much more likely to fail. That's that red arrow where we go across product development, we develop prototypes, we scale it up, and then we show it to a customer. High likelihood of failure. We don't have the right input. What we call lean development is where we're doing the opposite, where we focus, and this is really the way our product commercialization process is organized, that at the very beginning it's an awful lot of marketing work, really understand a lot about the market, then do product development, and when you do that, you're much more likely to have success at the end of the day. More often, what I find is we're actually doing more, and it's not mutually exclusive, but this agile line illustrates something a little bit different. That's where we have early prototyping, and we try to get something out as fast as we can and get feedback from the customer. So it might not be anything we could possibly commercially do, but it's something to get the customer to talk about it. And we have a series of wraparounds throughout that line. So it's more of a balance between the internal development and the external development at the same time. So we're saying we need to get out of the office and talk to the customers to understand their needs while we're developing an offering that will meet those needs that we're hearing about. So that's the innovation process. Statistics is really useful in these cycles. So using the sequential knowledge gain, basically we're talking about the scientific method here, or doing experimentation and an iterative problem here. So whether it's market research, whether it's solving some technical problems, introducing the results to the market, and going forward, statistics is really going to increase our speed as we go through this. Because what we're doing is making a series of decisions, and we really need to have confidence that those decisions are correct, or understand the risks. There's always a risk in development. Understand the risks and know how much risk we're taking forward with us. So using statistics along this path is really going to be helpful. I want to make a comment about statistics in innovation versus statistics in quality. I think there's a parallel here. I've heard some talk in the past about changing, I don't know if they were going to change the name of American Society for Quality, but there was some use or discussion about using these words interchangeably and using innovation instead of quality. I'm not a proponent of that. I don't support that line of thinking. Although I do think statistics and statistical thinking is equally important in both pillars, but I see them as different pillars. I see quality as primarily interested in improving things and making sure things stay consistent and we have good production and release processes, and we're improving operations. Not exclusively, but I see quality in the context of getting things done and getting things done excellently. And some of the tools that are involved there are Six Sigma, DMAIC, Lean Six Sigma, the 7 basic quality tools, statistical process control, quality assurance, all those things, standards. And on the other side of this picture is the other pillar, which is research and development, where we're more interested in diverging and seeing lots of variation and understanding the variation. And so using that variation to come up with designs that are robust, will be easy to control in operations. We're looking for marketing and marketing decisions. We're looking for development decisions so that we set things up well to be able to run it's designed for Six Sigma, not designed then Six Sigma, right? So we want to make sure that we're understanding all the sources of variation and deliberately changing things so that we see variation in a way that we can then come up with the best robust designs of products, of processes, of measurement systems, and so forth. So the tools there are some of the same, but we've got design for Six Sigma in there, things like quality function deployment, lots of experimentation from screening through response surface, methodologies such as trees, and other creativity tools. So I think they're different, but I think statistics and statistical thinking, or systems thinking, another way to say it, is really foundational for both. And so where I'm focusing here is on the innovation side, and this is just, what I'm saying is innovation is about making the right things, and then quality is then continuing to make them right all the time. Hope that makes sense. Any questions at this point? This is a time when I'll go ahead and take a break before I move into statistics or statisticians in innovation. So let me see if I don't have any. I think this, yes, yeah. It says, could you see my chart?
So there is one question, Kim. Can you see it, or would you like me to announce it?
Well, you can announce it if you want, because they're really tiny for me.
Okay, I can. I certainly can. So there's a question from Wayne Fisher. The question is that he says, interesting, logical, but many stories about fulfilling needs customers didn't know they had. Case in point, Post-it notes. Your thoughts?
Yeah, good question. I would suggest customers don't always know the solutions, but customers know their problems. So it's important to have conversations with the customer, not on what do you want from us, but on what job are you trying to complete. So what is the job that you're trying to do, and what problems do you encounter? And then thinking about what might I do to solve those problems. So in that sense, they know what their problems are. They might not know the features of a product that give them the solution. Okay, so while I say focus on the top customer needs, I'm not talking about product features as much as if I solve this problem for the customer, they're going to be really happy. And they all know, because they live with day to day, what their problems are. So in that sense, I'm saying that. But you also bring up another thing is you don't always know. And I work in the growth division of electronics and communications, so I'm very much in the area of market segments don't really even exist out there for some of the stuff we're looking at, and how do you know where to go? And that is a good challenge. You don't always know, but again, you know what problem you're trying to solve. So if you can watch people and see what they're trying to accomplish, and then it's the innovation, then that's where the brainstorming comes in, and the creativity, and trying to think outside the box of what are the different ways you could approach this or eliminate their problem in some way. So that's, I would say, a creativity thing. It's not, and that's one of the differences. Yes, you need creativity and quality, but that's one of the differences between innovation and quality. Is by the time you're managing quality, they know what properties they need very specifically, and they can tell you your dimensional stability isn't good enough. And so that's more of a designing quality kind of thing. But if you're trying to invent or come up with new products, like the Post-it notes in your example, you're more, what problems are you trying to solve? And what behavior is becoming common? And what tools would enhance that behavior? So as long as you're focusing on the customer's job to be done, you're probably more likely that they will know what they need. I hope that's okay, Wayne.
So there, Kim, there is another question. So that you can actually pop out the questions part.
There you go. Yep.
And make them bigger and easier to see.
Yeah, I have that. How does the two statistic and quality diverge? I'm not sure I understand the question.
So
Statistics.
I think Henderson said a little later that you had just answered his question.
Okay, great.
Their answer.
Thank you. How do you help impact the development of the innovation pillar from a traditional role in the quality department within operations? Aha, I don't think you do. Good question. I struggle with that. And we struggle with this across the board, not just in the statistics profession or quality profession, but in marketing as well. How do you need dedicated resources on growth. And those people that are working on quality are not necessarily skilled and gifted in the same way as is needed in innovation, but organizationally their objectives and their alignment is different. So I would not suggest you try to do the innovation work from operations. You'll also be thought of differently if you're coming from quality within operations than if you're part of the R&D organization or part of the marketing organization. So what we've done is we have growth organizations and you work for growth. And marketing is the same way. We have some people that are just out there to sell, or come up with what's the marketing plan for my current portfolio when we need marketing people to work on what are the needs of the future. And how do you do that? So organizationally, I think it's very important to have a support to innovation organization separate from the quality organization in operations. Great question. Let's see. My question was answered. Okay, that's how is the statistician organized within the organization? Are there return on investment? Let me get back to that one because I'm going to talk a little bit more about that one in the future. I might not get to the answer, and if I don't, ask it again. But I am going to talk about statistics and organizations. I don't know about, return on investment. I'll try to remember that when we get to it. So I'm going to move on at this time, if that's okay, and talk more about statistics and statisticians in innovation. So I've talked more about the innovation process, and I'm going to talk about these 5 points. These are the things that I think statisticians do, or we. I keep saying I, and I apologize for that because Willis Jensen was on this paper, and some of these ideas are his as well as mine. So providing a holistic view and systems thinking approach, bringing an independent perspective, promoting the use of statistical tools in both R&D and marketing, and facilitating problem definition. And then I'll get to, and of course, enabling the whole organization to use statistical methods more frequently and more appropriately. So we're problem solvers as statisticians. That's what we do. And the first part of problem solving is the context. So the thing I like about being a statistician is that I didn't have to decide what I wanted to be when I grow up. We basically can play in anybody's backyard. That was a quote from Tukey, and I love it. The cool thing about being a statistician is being able to play in everyone's backyard. And I'd say with innovation, we also see how all the different backyards fit together to form a neighborhood. Or from any leveraged industrial or applied statistics organization, you're working on lots of different problems, and your clients might not even talk to each other, but you see different aspects and different views of the same problem. So you're able to put these parts together into a more holistic or system problem and approach the problem more efficiently that way. So that's something statisticians bring. And when I say statisticians, I'm typically talking about those found in industry as opposed to in academia, just because I don't know much about those in academia. I've been in DuPont for 28 years. So I don't know a lot about statisticians in academia, but those that are consulting and dug in to an organization or to a corporation will get to see problems from lots of different angles and will be able to provide this holistic view. And that is huge for how to solve the problem. That's even becoming more important as we move toward things like the Internet of Things, where this is more hype than anything else at this point. I believe, but as we start looking at smart bedrooms and things being connected, you wake up in the morning and your alarm clock tells the coffee pot to make a pot of coffee, and when the coffee pot gets down below a certain point, your car starts, or I don't know. But all this connection of Internet of Things is very much collecting data and processing information. We're sensing things, we're connecting things, we're aggregating things and analyzing it, and statistics is going to become a part of all of that. And so this systems thinking is something that is very difficult for many disciplines, but statisticians tend to have a very systems approach, a very strong systems approach to problem solving. So as we move into this area, I think this aspect of providing the holistic view and systems thinking will become even more valuable. And in these kind of areas, we actually get paid for that. I mean, the data and the analytics are actually the unit of sale in many cases. The next one, I'm going to be pretty brief on all these because it's a pretty short webinar. The next thing that we bring is an independent perspective, that we are not, the problem that we're trying to solve is usually not our own. It's a client's, or it's the organization, or it's the businesses, and we can separate ourselves. We are not necessarily the chemist that came up with this, or the design engineer that is trying to push their own solution. We have a data-based approach, and we can make statements with confidence or without confidence. And so this whole idea of having an independent perspective to making decisions is huge. Because you can just, when arguments start or disagreements are brewing, you can ask the question, well, what information do we need to make this decision? And we have processes that we can use to facilitate making those decisions, whether they're decision trees or decision and risk analysis, some kind of probability-weighted financial model, whatever. But we've got an independent eye to bring to the problem and help folks make sound decisions based on data. Another reason we're good at this innovation stuff, this is just showing where the decisions are made. So in our process, this is pretty generic, so we say it's our process, but most development processes are in some way of stage-gated, 5-phase process. We've mapped Six Sigma to our process, so we have, or designed for Six Sigma. We've got measure, analyze, design, verify, realize. Now, of course, we've got a whole lot more in there than the design for Six Sigma pieces to develop a new product, but it's basically a 5-stage process. The key decisions that are made are what drives the process. So all the work that gets done before you start a project has to be organized in a way such that you can answer the question, is this idea worth looking at? Yes or no? So the work that you do before that stage review is to provide input to answering that question. The work that you would do in our stage 1 or concept evaluation is all around customer need and what is the job that they're trying to get done and what problems do they have, and is this, if we solve this, is it a high priority for them? And getting to the question, do we have a compelling value proposition? If we can do blank, will the customer be waiting and lining up, customers be lining up to get this? So do we have a compelling value proposition? So these are the decisions along the way that we're trying to make, and the work that gets done in this stage is in order to present data to support or not support these decisions. Sometimes it's not as formal hypothesis testing at this high level as you might like, but just the systems approach and the thinking to that and data that addresses the specific question in mind is a huge help. And of course, some of the sub-decisions down underneath will be addressed by specific hypothesis testing and statistical analysis. So this helps us understand what do we know and what don't we know as we answer these questions, and then we can talk about risks and some probabilistics and things like that. So database decision making by people who are independent of the problem is something that we bring. The use of statistical tools throughout the process, this is where I said you'll see this list again. These are just the ones that are most used. I'm sure there are a whole lot more, and some of these are pretty general and all-encompassing. But early on, we're designing surveys, or we're doing conjoint preference studies, quality function deployment, Kano. We're using pricing models. And pricing models might not sound like a statistical tool, but when I do a pricing model or a financial model, I put in 10, 50, 90s, or high, medium, and lows, and I run experimental designs on what are the inputs to these models, and revenue is the output. So what is this model most sensitive to in this case? So there's statistics and statistical thinking on every level throughout this. But early on at surveys and those kinds of things, more customer-facing statistics. Stages 2 and 3 are a lot of fundamental, basic industrial statistics. You're doing hypothesis testing, rating and ranking, and those kinds of things, developing measurement systems, a lot of statistically designed experiments, some messy data, simulations perhaps. You might be creating black boxes to do some simulations. You're testing prototypes, all kinds of data analysis here. You're probably doing interlaboratory comparisons. You're looking at scaling up from lab scale to pilot scale to plant scale, so lots of different process development methodologies. All through this, we're trying to move really fast. And some people will say, I don't have time to run an experiment, or I don't have time to do the statistics. Well, honestly, it is the quickest way. As I'm preaching to the choir, I know that this is objective-driven experimentation. So if you really want to collect just the data you need to make decisions, use statistics. So it really will help you move through the process. And if you're leading these projects, you have authority to kind of force that issue and say, no, we're going to do it this way because we're going to get better answers, and we're going to know sooner whether or not we should move forward or not. Remember that a good answer can be, no, we're going to stop. So all these red, maybe I assume too much, but these red diamonds are points where you stop in the process and say, okay, do I have enough evidence that it's still prudent to move forward or not? Have I looked at this enough? It doesn't have any merit. I'm going to move to the next thing. So every one of these red diamonds is an opportunity to stop the project or continue the project. So that's what we're looking for, is do we have enough data to move forward? Some examples of where we've used statistics to direct innovation along the way. Early on in setting design goals, again, this is where designing surveys is the key. Different forms of surveys. It could be Kano, it could be quality function deployment kinds of things, it could be conjoint, Kano, what did I say? I think I said all of them. But anyway, those are the ones that we most typically use, where we're listening to hear what kind of information do our researchers need to be able to develop something, first of all. And it depends on how new your new invention is. Is this a new film and you already make films, or is this a completely new device that you're not even in that space? The kind of information you're going to need is different. So listening to find out what kind of information do I need from where. Let me design the survey. Who do I need to collect that information from? And we understand a little bit more about how to conduct a survey. They call it market segmentation. We might call it, I'm losing the name, but stratified sampling in our survey methods and so forth. So then we analyze the survey results to say, what did we learn, what didn't we learn? Sometimes we don't have enough customers to do statistical sampling. So then we're just looking at ranking and things like that. But often we do have enough data to do statistical analysis of that. But basically, we're trying to be realistic about what do we know in order to set clear criteria for the value proposition. What is it that we need to make? What criteria has to be met for a successful new product? So a lot of statistics there around the area of survey and survey analysis. And then as we move forward, if I had an example where the value proposition was clear at the beginning, but things kept changing, the market changed, we hit some snags in the technical space where we weren't able to do everything we hoped we could do in the original value proposition, and it seemed like, okay, so these people won't buy it now, or those people won't buy it now, and when do you get to the point that it's no longer worth doing this project? And so we used criteria-based decision matrix, again, kind of loosely stated as a statistic, but to reevaluate the value proposition. And in that case, we basically use statistical thinking and framing of the problem to say, no, this is no longer compelling, and we redirected the resources away from this work. Another one did a DOE, this is a while back, ran a DOE on a specific material. We were hoping to develop this new process out there for making toothpaste tubes. It was a long time ago. And we ran a DOE to show how to use our special super duper material in this new technology application. And we did. We were successful in the DOE in showing, yep, you can use this specialty super duper material to make this tube. But it also showed that, with just a little tweak of the process out there, they can figure out how to use it with the cheap competitive stuff as well. So we realized, you know what, it's not going to be long before people figure that out in the marketplace. We're not going to bother developing this new technology for this super duper material because you can use this new technology with the cheap stuff too, and we have nothing to gain. So we stopped that project and didn't invest in that development. So these are just a handful of examples. Here's another whole page of the kinds of things we run into all the time, where statistics can really enrich the conversation. So 3 lots are needed for turnover to manufacturing. I don't know what you have in your businesses, but this is a legacy practice that I don't know where its roots are found, but it's pretty permeated throughout DuPont at one point, where everybody needed 3 lots before we could turn things over to manufacturing. Well, that's 3 data points. That's not a whole lot of confidence, depending on what they mean by 3 lots and how much statistics and how much data and all of that. So, whether or not that's appropriate really depends, and we can improve that turnover process, and we have improved that turnover process by being involved in that. By saying, look, you can turn it over, but you still need to keep collecting data until you have the confidence. And so, recognizing how to calculate the capability and so forth, and collecting data and upgrading that measure as we move forward is current practice. So we've done it once, so let's go commercial. I was on a project, a really important project. Everybody loved it, and we've shown that we can do it, so why can't we make it happen? Went on for year after year after year. Well, we got lucky once, and we saw one really cool result. Doesn't mean we understand the process and that it's repeatable. So using statistics, we can show that. We can say whether it is repeatable or whether it isn't repeatable pretty quickly with one experiment, one DOE type experiment. So that's a practice that we can dispense with. The data doesn't meet the specs, and we don't have any knobs left. So I've heard that, but often folks aren't looking at interactions. So, or interactions between materials and process step with the following process step, and so forth. So often it's not the knobs themselves, but how the knobs work together that do this. So statisticians know how to look for that. We need the customer to evaluate a certain property. We can't measure it ourselves. We get into this a lot, but we can develop measures that map, some internal measures that will map or be predictive of what the customer might find, or maybe a couple measures that together will help to predict what customer results will be. And so we can, as statisticians, we can do that early. Might slow things down while we're doing that, but it'll certainly speed things up in the long run. We had a group of folks recently go through some DOE training that they changed the speed with which, when a customer asks for a new product, it used to take them like 3 weeks to come up with a few ideas or a few candidates to give them to see if they'll work for them. It is in the semiconductor industry. And now through DOE, they've got models and so forth that they can use. They can now evaluate something for a customer. When a customer makes a request, they can send out samples for them to try in hours rather than weeks. because they really know how to map their internal process to the request that customers might be making. And so forth. We can use DOE to increase the evaluation likelihood of success, reliability calculations are something we can do. And I always hear we can't schedule an invention, and that's true, we can't. But the reason people are saying that is implying that you can't use typical project management for R&D, but you can. It's just hypothesis driven, and when you're using experimental design, you can, or statistical methods, you can understand, line up the hypotheses, how long and what kinds of experiments might we need to test these hypotheses. And so you can do a different kind of hypothesis driven project management if that's what's needed. So these are just some more examples of where statistics is really important for driving decisions. And if you're leading the innovation, you can make sure these kinds of things are happening. So being in a position, maybe not the overall leader, although that's fine, that's what I do, but you could be an influential position on any project team. And the last one here is statisticians, before I get to training, I think it's really the last one, is facilitating problem definition. And this isn't anything new here. Back in 1992, Heilmeyer had these critical questions for framing a problem. They're still right. I still think they're right on. And all I've done here is add some wording for twisting these, giving a twist to these for the innovation space. So really knowing how to look at the problem is going to save time. And it's amazing how we have the capability of doing that often. Because we always had to kind of take a physical problem, translate it into statistical terms, solve the problem, and then translate it back into layman's terms for communicating the results. We just do that. And so that gives us a capability that others don't naturally have to facilitate the problem definition. So what are you trying to do? How's it done today? What are the limitations of current practice? And so forth. How long will it take? How much will it cost? How are you going to test success? All these things are still true, and we bring that to the table just by the way we do our work, typically. Rewording for innovation, some things you might want to add to this is not only what are you trying to do, but what's the most important problem to the customer or the biggest need. How's it done today? Specifically, if we don't do this, what's the next best alternative, next best competitive alternative? That's what we have to beat. What are the limitations in the current practice? Something to add on top of that is how important is this gap or this limitation to the customer? Why are we the ones to do this? What capability do we have that makes us the best candidate for doing this? What does success look like, and how does that help the customer get their job done? That's really how we have to look at success. Because if we have added features and it doesn't do anything for the customer, they're not going to buy it. So the features and the things that we're developing have to be related to helping them get their job done better, faster. So how long will it take? Why do I care? I have to beat the competition. And again, I have to know what the investment's going to cost relative to the revenue that I can make. And then how am I going to measure progress? That's pretty much the same. So really staying focused on the problem will save time and will keep us moving in a direction with some speed. So at this point, the last thing is teaching relevant statistical methods. Recommend doing this on the project. So as you're working on the projects and you're using statistics to do some of these things, to design the survey, to learn about a process, to define features, share it with the team. So this is a good opportunity for hands-on project-based learning for the rest of the project team as well. And whenever possible, using graphical methods is the best way to communicate the results. Don't try to show all the statistical know-how that we have, just the answer, and that the tool gave them the answer. And the best way to do that, in my opinion, is through graphs. So these are the skills. So that's what I went through. I think before I get into the skills, this might be a good time to stop for a question or two. I don't have much left, but I do want to, I know I'm running low on time here. So how is this, let's see, where am I? Trying to find the first question. Can we get a copy of the slide deck? Who's that a question for? This will be posted. I think you'll hear about that after the presentation. Sometimes the objective is simply to replace the current material with a new and less expensive material that still has material properties that one needs. Yep, true. And I wouldn't say that's a big innovation project. That is a definite statistical problem to solve and to prove that they're the same, but I wouldn't say it's a big innovation necessarily, unless a whole new technology is needed and then a lot more comes into play. Can you give an example of how you have done the hands-on project-based learning? Well, we do Six Sigma is one thing too, so we have people solve their own problems, but an example. Every project that I've done that's been a new product development has involved experimental design, and so the whole team is involved. They might not really understand at first, but they're involved in what are the variables that have to be, that are candidates for influencing this, what are the processes that we have to involve, and we design experiments together, and then they run them, and I do the analysis or have somebody do the analysis, and we talk and we interpret the results, we learn from them, and we move on to the next experiment. So I've done it with photovoltaic paste. I've done it with new films, new laminate structures. Just about anything that's a new product, you need to run experiments. So we do it together as a team. And that's what I mean by hands-on project-based learning. It's not necessarily teaching. We also do teach experimental design classes, statistics classes, Six Sigma, and so forth. So people learn that and they do their own projects within the context of an innovation project. So we have a lot of people doing projects within projects as well to get certification. More in the past than current, but we're still doing some of that. But the DOE stuff is still being taught to project team members and being run on project teams. So I don't have time to go through a specific statistical example right now, but I could list them at least without going through them. Teaching statistical methods. You mentioned earlier DOE training, classroom, I presume, and just how project-based learning. Which do you think is more effective? Aha, good question. In innovation, DOE is, what we've decided in my part of the business is that project management and DOE are two of the competencies that our researchers need to have. So we do experimental design training. We do it around the world. We do classroom. Now it's got a lot of hands-on, but they're handcrafted. I mean, they're false projects in the classroom. But then we have a day at the end where the students bring in their own projects. We're giving a certification, a green belt. This is new for electronics and communications. We're giving a green belt on DOE. So that means if you take the training and then you actually do a DOE, you define the problem, you know the X's, the Y's, you've done your measurement system checks, you run an experiment, you get the results, you analyze the data, and you implement the results, you're going to get a green belt. So that's kind of how we do it. So they're real product development problems that people are doing that follow up their training. These are good questions. Great presentation. Since quality engineers interface with customers to determine their needs, but how does statisticians show their worth within the company? Okay, so that's the same as the ROI. I don't know if that's the same question or not. Frankly, statisticians have to speak the language of the business. So as we're dealing with problems, whatever they are, if they're product development, you know, you have to show that you are bringing in the information that's needed to make the decision. So be right up front, but you have to speak the language of the business. So if it's the financial model, talk in terms of financial model. If it's saving time, say, well, if we use this experimental design, we can develop this in this amount of time. These, you know, so I think you have to present what you're doing in the context of the problem that the business is trying to solve. And what I'm talking about here is being able to do that from a position of leadership, that once you can demonstrate you can do that, they're going to, I mean, I have been in a position of project leadership for years now, and I think it's a really good match, and this is why I think black belts and people who have strong statistics, master black belts, people that have strong statistical capabilities are really good in these project leadership roles for all these reasons. Not every statistician. If you like to sit at the desk and crunch numbers and present tables, maybe project leadership and innovation is not your thing. But if you are an integrated statistician or an applied statistician that speaks the language of the business, you're going to be able to show your worth. But it's always in solving their problems and financial and time. That's how businesses speak, really, finances and time. So return on investment, you know, when we get in DuPont, one of the things for getting a promotion above a certain level is you need to show how much money you made for the business. So while you don't always want to say this DOE and my involvement separate from the rest of the team did this, you want to be able to show we as a team made this amount of money, and you know, I was a key player. I was, you know, the methods that I brought to the table were the key methods that we used, or some of the key methods, and basically getting testimonials to that effect. But the work you're doing actually has to result in money. And so always ask, before you get involved in a project, ask, what's the financial gain? You know, what's the company going to gain if we do this work? So whether it's cost savings or revenue generation, you really need to understand the finances. Okay, I'm going to move on. We're just about done, and I know I only have 3 minutes. These are the skills I think statisticians need in innovation. I'm going to jump through each one. Just recommend this book, The Ideal Team Player by Patrick Lencioni. I love this. He says every team player needs to have these 3 aspects. They need to be humble, they need to be hungry, and they need to be smart. And by smart, he means people smart. And this is a really neat, take a snapshot of this picture if you're not getting the charts, but I think they're going to be on the video. You need all 3 of these. And so look at this and say, where do I sit on this? And read this book, The Ideal Team Player. It gives you some good suggestions on how you might develop yourself as an ideal team player. Plus, it's a quick book. It's very similar to The 5 Dysfunctions of a Team in that it's a story. So it's a great book. You need to be an ideal team player. You need to have a broad understanding of other subjects, and this goes to understanding your ROI as well. You need to be able to understand some business, some marketing, and some finance. IT to some degree, sales somewhat. You need to be able to sell yourself, and human resources. You really need to know how, if you're going to lead a team, you need to know how to manage people. So human resources and those kinds of things are important. So try not to limit the education that statisticians get in the future to just statistical technique, but broaden them into all these other different subjects. But that said, I think we can bring statistical approach to every one of these areas because we ask, what's the question, what's the information needed to answer it, how are we going to get it, and then how are we going to look at the metrics, how are we going to, what statistics are useful. So while I'd say we need to learn the language of these other areas, we also bring something to the table in every area. Here's a model that we use for managing competencies. So when you talk about statistical organization, if you want to look at this, how we recruit, we need to recruit better, well-rounded people that are team players. Of course, they have the statistical competency, that goes without saying, but they need these other things, maybe even more than really PhD level statistics. How we manage that talent is, you can look at different models for how you're going to promote people or what kind of behavior you're going to look for, what roles you're going to put them in, how you're going to measure performance, both by employee and across the organization, what kind of training you're going to give them, and again, get them outside of the statistics core and broaden it out a little bit with some creativity, maybe project management and team leadership. Organizational assessments on how do you use statistics is another good way to look at this. So this is the way to measure your statistical competency as an organization. Here's a chart, and I know I'm out of time, so this is just project leader training, covers all of this stuff. So I would very much recommend that statisticians get some project management training or project leader training. And all of these things are included in that. So good statistician and good innovation leaders have to be balanced. If you're going to be a statistician in an innovation role, you need to be detailed, but you can't be too detailed. You have to be picky and demanding, but not too restrictive. You need to be uncompromising with some things, but not with everything. Deliberate, but you can't be too slow. And no matter what, you have to be excellent with people. So these are the things that statisticians they bring to the table, but they also have to worry about bringing too much of it to the table to have that right balance. So it's up to you to decide whether or not you're cut out to be an innovation leader, but I would say innovation processes need statisticians, and it's really fun. So I would encourage you to get into it. And with that, I am finished, and it is 1 o'clock. So Adam, are you still there?
I am still here. Kim, thank you very much for the wonderful presentation. To the attendees, we ask that you complete the short survey at this time that will, I believe, pop up within GoToWebinar. A recording of the webinar will be available within a few days on the division's YouTube channel at youtube.com/ASQStatsDivision. Please be sure to share this webinar and our other archived webinars with your friends, coworkers, and colleagues. We also encourage you to check out the division's LinkedIn page as well as our events calendar, which can be viewed at asq.org/statistics for the latest news on webinars, conferences, and many other topics. That's all the time we have for today. It's slightly after 1. Thank you, everyone, for joining us, and thank you again, Kim, for presenting with the Statistics Division. I hope everyone has a wonderful afternoon.
Thank you, Adam.